Dear children, most importantly, we must understand what exactly a node. So, to understand about the node, let us just recall the definition of orbital. When we consider orbital, we say that it's a region around the nucleus where the probability of finding electron is maximum. That means in that particular region, the probability of finding electron will be maximum. So that's known as orbital. Exactly opposite of orbital will be node. What do you mean by node? Node is a region around the atom where the probability of finding electron will be zero. In that region, you cannot find the electron. What is the condition for node? The condition for node is the value of psi square. Psi is a wave function. As I mentioned earlier, it can have values like 0, positive or negative. Psi square. If psi square value is equal to 0, that indicates that it's a node. When psi square is equal to 0, that means you cannot find the electron in that particular region. There are two types of nodes. One is the radial node, the other one is angular node or planar node. So what's the other name for radial node? A radial node is also known as a spherical node. Spherical node. Now, if you consider a radial node, so radial node means, let us take a diagram, quick diagram here. Yeah. So this is the diagram which I want to speak of. So this is a representation of a radial node. So when I say radial node, there is a radius. We are thinking of a spherical surface. So this is a nucleus. This is a nucleus. And this is a size of what? 3s orbital. So you have 1s, 2s and 3s. As the principal quantum number increases, the size also increases. Therefore, the size order will be equal to 3s greater than 2s, then you have 1s. Now, if you consider 1s orbital, so this is a nucleus. From this distance around the nucleus, so everywhere you can find the electron. Therefore, here in case of 1s orbital, the probability of finding electron is equal in all distance here, in all distance. If you consider 1s orbital, so you can see this white color thing, right? So this is a nucleus and this is a maximum distance. Now, in this particular region, so here I am representing, in this particular region, around the nucleus, when I say around the nucleus, at a certain radius from the nucleus, where the probability of finding electron will be 0. That's known as node. Therefore, for 2s orbital, there is only one node or only one region where the probability of finding electron will be 0. Similarly, if you consider the 3s orbital, you can look at here, there is one region here at a certain distance from the nucleus where the probability of finding electron is 0. Again, after certain distance, there is a probability. After that again, there is a probability of finding electron will be 0. So, if this region represents the probability of finding electron is 0. Therefore, when for a 3s orbital, there are two nodes are there. For 2s orbital, there is only one node. For 1s, there is no node. Again, you can see this diagram also. So 1s, 2s, see whatever this color which is represented here, this represents the node. Similarly, for 3s orbital, here there is a node. Again, here also there is a node. So what do you mean by a radial? All these are examples for radial node. Now, what's the meaning of radial node? Look at this definition now. A radial node or a spherical node is nothing but which surface we are talking about? A spherical surface at certain distance from the nucleus. At certain distance from the nucleus, there is a distance where distance from the nucleus within the orbital itself, on which the probability of finding electron is 0. And a certain distance, you can see that the probability of finding electron will be 0. Now, how do you calculate the number of radial nodes? Number of radial node can be calculated as n minus L minus 1. N is a principal quantum number, L is azimuthal quantum number minus 1. So they've calculated for 1s, 2s and 3s. So likewise, you can calculate a radial node for each and every orbital. Similarly, we have something known as angular or planar node. See, the name itself indicates it's a plane. It's a plane. It's a plane passing through the nucleus on which the probability of finding electron will be 0. It's a plane passing through the nucleus where the probability of finding electron is 0. The number of nodal planes, how do you calculate it? Equal to L. What is L? L stands for azimuthal quantum number. Therefore, for a given orbital, you can have two types of node. It is radial node and angular node. How do you calculate the radial node? N minus L minus 1. Then planar node or the angular node will be L. If you add both of them, the total number of nodes will be equal to N minus 1. So to have the clarity on what exactly this planar node, so this is a diagram I would like to show you. Look at this. This is a px orbital. When I say px orbital, the two lobes are along the x-axis. When I say two lobes are along x-axis, these two lobes touches this point. And when you place an imaginary plane here, this is a plane which we are talking about. This is YZ plane. The lobes are along x-axis, therefore the YZ plane becomes the node. So that's also known as the planar node. Similarly, if I consider PY, the two lobes are along y-axis. Therefore, if I place an imaginary plane, that is XZ plane, that becomes the node. Similarly, if you consider PZ orbital, so the XY plane becomes the node. Therefore, planar node means it's an imaginary plane where the probability of finding electron is 0. Similarly, when we consider radial node is nothing but it's certain distance from the nucleus, where it is a region around the nucleus where the probability of finding electron is 0. And the total number of nodes will be equal to n minus 1. So radial node is this much and angular node is L itself.